Hi everybody, welcome back to my YouTube channel. I hope you guys are doing great and staying amazing. And today I'm going to be tackling one of the questions that this came back this year in the WIZARI exam, and I just want to go over it. Well, it looks very intimidating, but it's not. It's actually not that intimidating as well, I suppose, as it looked. All right, let me just draw. Okay, it says, actually, let's read it, then we're going to draw. It says, a meter stick is supported at its 50 centimeter. Can I not? Right, hold on, draw. Okay, right. Okay, a meter stick is supported at it is 50 centimeter by a string attached to the ceiling. Okay, I want to first of all draw you guys a picture. Oh, not so good. Hold on. Okay, let's assume that's a meter stick. And at the 50 centimeter, okay, at the 50 centimeter, we have centimeter mark. We have, it's, hold on. At the 50 centimeter mark, attached to a ceiling, okay? It's attached to the ceiling, so it's tension force, okay? Ft, okay? A 1.2 kilogram mass hangs vertically from the 70 meters, okay? It's hangs, okay, so that be like this. And let this be 70 centimeter, okay? Okay. By the way, it is 1.2, but we're gonna add that later on. It says, and an 0.6 kilogram mass is attached from the 30 centimeter mark. Okay, it's about this much. 30 centimeter, okay, about that much. And it says that it is attached, so it's like this. So here it says, by a string attached to the ceiling, so it's attached to the ceiling. It's an F tension force, and it says hangs vertically, so that's correct. And it says an 0.6 kilogram mass of is attached from 30 centimeter mark. Well, what? Yeah, I did that. Find the location of the point where the 0.4 should be placed. Okay, where there's a state of rotational and translational equilibrium. We know that in a rotational, F torque means the net torque is 0. And for translational equilibrium, these are the conditions that we need to apply. All right, now what I want to focus on is that we do really have, what's it called? Let's tackle this one first, because this one requires distance, and I don't know what the distance is. All right, so I'm gonna tackle this one first. You know why I will tackle the force first is because if I went ahead and if I did the torque, then I would have two unknown. Okay, I would have two unknown, because the first unknown, would be that I don't know what this force is right over here. I wouldn't know what this force is. So how could I go and deal with two unknowns at the same time? This is just like an unspoken rule, So I cannot go ahead and do that. Instead, I will find the force first, and then I'll move to the torque. Okay, so how to find the force? Well, the force says up and down force are equal. Okay, it says should be attached. Okay, let's assume it's somewhere. Okay, it could be anywhere, but let's put it here for the sake of understanding. It says it is attached. Okay, it says it's attached, so it's downward. Okay, so that would make force upward, force downward. Ft for upward equals 0.4 times 9.81, or you could do actually something else. You could go ahead, since we want to find the force, well, we could do something else. Let me just do that. That's quicker. Plus 1.2 plus 0.6. Now let's calculate all of that. So 0.4 and 0.6, that's 1, plus 1.2, that is 2.2. Okay, now 2.2 as in mass. Okay, convert it to force. That would be 2.2 times 9.81. That would be, let me see if the calculation is correct, because that did it times 9.81. Yes, correct. The app did it on its own. Okay, that is as in Newton. Okay, we found the upward force. Now this upward force, I'm gonna regard it as like mass, because everything else is in mass, but I'll just write 2.2 kilogram. Okay, all right. Now as for the torque, I will go and put my axis like at the end. Okay, like any of the ends that you want, I don't mind, but I'm going to take this one. Okay, I'm going to take this one, just because if I take this one, I would have to, like, how do I say it? I would have to draw it again and to deal with, like, for example, this is 30 centimeter, but if I change it to there, it's, I don't know, whatever. I just want to go with there. If you do it the other round, you're gonna be correct, because then for this 30 centimeter, you're gonna pick like 70, and for this one, we're 30, and this one 0.5. Same, actually, same thing. I just want to go with here, like that's. I just would love to start from the left. Anyways, I sounded too deaf. Anyways, as for torque, let's regard this as our axis. What happened here? Axis. Yeah, just go with that. All right, and then if I want to make that my axis, this would be clockwise, and so would this one, 0.4, which is 0.4 by the way. 0.4 was 0.4, 0.6 kilogram, 0.4 kg, and this is clockwise, 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 counterclockwise. Now you know what to do. All right, so we're gonna deal with that now. So I want you to go ahead and do this, okay? So we have, keep everything in centimeter, because even the answer is in centimeter. It's like, all are in centimeter, 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 centimeter. Okay, so I don't have to convert. So 30 times, what was this force over here? 0.6 plus confused nakam. I tackled the clockwise on the left side, okay? And now I don't know the distance, but 0.4. By the way, I forgot something else. Okay, 9.81. Okay. All right, plus 0.4 times. Actually, you know what I'm going to do? I'm not going to write 9.8. Why? Because on both sides, if I write 9.8, I'm going to cancel out the 9.8. That's why I didn't even bother to write the 9.8 now. It's because they'll cancel out each other. I won't do it. 0.4 times, let's say, x. Actually, x is confusing. Let's put, I don't know, a. All right. And plus 1.2 times, was it like 50? No. Was it for the 70? Yep, it was for the 70. All right. That's beautiful. And now equal. No, wait, hold on. Don't do that calculation yet. Okay, so the 50 mark, we have 2.2. So 50 times 2.2. Do the math now. Solve for x. Solve for a. Let's do it. Bring out your calculator and do it for a. So 30 times 0.6, that's 18, plus 0.4 a plus 1.2 times 70, that's 84, equal 50 times 2.2, 1010. What is this? Okay, now solve again. 1110 minus 18 minus 84, that's going to be 0.4 a equal to 8. Solve for a. A is equal to 8 divided by 0.4, 20. And I gave it in centimeters, so 20 centimeter. That's why B is the correct answer. Now I want to say it again. The reason why I tackled the force first was because if I did the torque, then I would have two missings, okay? The first missing would be like, what is the mass over here, okay? And and then I would be like, what's the distance from the 0.4, okay? Then I wouldn't know. And another thing is that's why I tackled force first and then the torque first, then torque later on. That's why. Also, I need you guys to like focus on reading very well, because if you don't know what it means, you cannot get it right. Because like, for example, by a string attached to the ceiling, that just like shouts, tension force. Hangs vertically is like, hanging. No wonder. 0.6 kilogram mass is attached. Attached means that is like hanging as well. My bad. 0.4 mass should be attached. All right, that's you should know what you're studying and what you're talking about, like what it is talking about. So that's why I'll tackle question 10 in another video, okay? And another thing that I was like wondering about is that, look, guys, do not come for me and be like, what did you do? Like, what did you do in this step? The reason why I didn't write 9.81 was that everything else is given to me in mass, like it's in kilogram. So I did the kilogram part, okay? Even if I did it in like force, I would have to write 0.4 times 9.81, 1.2 times 9.81, 0.6 times 9.21. Then I'll just be like 2.2 times 9.81, and it gave me the answer, 21 Newton, whatever that is. Okay, and the reason for this part, why I didn't use the force, you could go ahead and use the force. I couldn't care less. That's just like wasting your time. But the reason I did it in mass is because then I would have 9.81 in this side, in the counterclockwise part, as well as in the clockwise part. And since it's gonna be like a common between both sides, just cancel it out. Save yourself some time, okay? So don't ask in the comments and be like, okay, I don't mind asking questions in the comment section, like you go ahead, you're free. But like, I'm just saying that, like, that's why I did what I did, okay? So I'm glad to be able to be lending you all a portion of how I think about certain stuff. Now, to make you guys feel better, I canceled physics, and the reason was because of this question. And the reason I'm making this video is that after I came out of the exam, I didn't check the exam, I didn't do anything, I didn't care, I left it, okay? I spent a week away from exam, whatever, like I didn't check the solutions or whatever. And then when I came back to it, I was like, before I see videos about it, or if I like ask from friends, let me try and solve it myself. In exam hall, I couldn't think about solving it because I was so anxious. took me 5 minutes at home to solve it. And I'm just telling you that, look, stress just ruined me first trial, so I don't want anyone else making the same mistake I did. Please control your stress and then go into WIZARI, because like, especially for the people that have khuli duam, like you have a bunch of time to just be like, control your fear, like to just control your fear. And something else is that fear it's because of the absence of action. And like I use that's the motto of my life. If I'm anxious about something, that means I didn't do well. Okay? And it's true. Listen to yourself. Anyways, I don't want to talk too much. Bye.